Hey guys, welcome to Runtime Terror. Today's topic is recursion. Recursion is often most confusing topics for amateurs and even for the experts. So hopefully by the end of this video you'll be able to grasp many confusing concepts and how to come up with your own solutions. Let's get into the video. So what is recursion? Recursion is basically a concept where a function calls itself until the problem is solved. Recursion is mostly used in trees and graph related problems, but not limited to them. And it often reduces the amount of code that has to be written otherwise. In iterative mode, there is a lot of code written. There are a lot of data structures used and a lot of code written, but the recursion helps to get away with all of that. And finally, any recursive function, guys, even if you encounter this question in an interview, be confident any recursive function can be converted into iterative function, because basically a recursion is basically just an iterative function using a stack. So the system uses a stack to store values. That's what recursion is. So a recursion function can always be converted to iterative counterpart using stack. So let's get into the classic problem using recursion, and that is Fibonacci series. So we'll start with this basic problem and then we'll get into the add digit problem, which is slightly more complicated, and in the next video we'll make one more or maybe a couple of more problems uh, which tells you more about recursion. So what is Fibonacci series? This is basically a series where, except the first and second, each number is a sum of the previous two numbers. So basically, sorry, 1 1 and then the third, from starting from the third number, each number is sum of the previous two numbers. So basically 2 is a sum of 1 and 1, and then 3 is a sum of 2 and 1, 5 is a sum of 3 and 2, and so on, so forth. So the problem here is to find the nth Fibonacci number. So we need two conditions. So basically the problem is, if this is the ninth Fibonacci number, this is the third Fibonacci number, so a function is given and a number is given, and that number, so we have to find the Fibonacci nth number. So 1 2 3 4, and this is the fifth Fibonacci number, sixth Fibonacci number, seventh, eighth, ninth, and so on. So what is the logic, guys? So in recursion there are basically two things. One is the base condition and two is the actual logic behind it. So first we would come up with the logic, and then finally we would think of all the corner base conditions. So even more so, let's get into the mathematics later, but first let's grasp of what recursion actually is. So we are trying to solve a problem, guys. The problem statement is simple. We need the nth Fibonacci number. So this is the first, this is the second Fibonacci number, this is the third, this is the fourth, fifth, sixth, seventh, and so on. So given a number n, we need nth Fibonacci number, and we denote it as f of n. So the procedure is explained in the next slide, in the next video. At any point of time to solve a recursive problem, we need two things, guys. One is the base condition, and two would be the logic. So as you progress, as you practice more, you would automatically get the intuition of what these are. But as of now, first always think about the logic, guys. It's easier that way, and then go to the base condition. This is similar to checking the edge cases. The base condition is similar to checking the edge cases in the normal non-recursive problems. So here the intuition is pretty simple. What are Fibonacci numbers? First thing, let's denote the Fibonacci nth number as f of n, and mathematically speaking, It's basically the sum of the previous two numbers. So intuitively, it's f of n minus 1 plus f of n minus 2. Now, recursion is pretty mathematical, guys. If you're really into mathematics, you're at an advantage because uh, the because terming the problem statement in the mathematical statement, almost 80% of the recursion is done, guys. You just have to think about the corner base conditions. As we progress in the video, I'll exactly show you how to think about it, but as of now, let's get into the mathematics. So the nth Fibonacci number simply is the n minus 1th Fibonacci number plus the n minus 2th Fibonacci number. It basically means f of n is just the sum of the previous two numbers. So what would this statement look like in a function? So let's say we are writing in C or C++. Let's say we have to return the integer. Obviously the nth Fibonacci number is an integer, so let's denote the function as fib n, and we are passing a parameter, just the nth Fibonacci number. Which number do you want? And now in this function, so let's ignore the base condition, we're just going with the logic as of now. So what we do is the nth Fibonacci number is simply fib n. So when you call, guys, just leave the function and for simplicity assume this is the int main in which you are going to call this function, which is fib n of, let's say you want the fifth Fibonacci number, guys. So this is how you're going to call. Let's say you print it. This is just a pseudocode. You're printing the fifth Fibonacci number. So f of n is the nth Fibonacci number, but in the code we are denoting as fib n of 5. Let's say n is 5. So now turn this statement into exactly the code that we have written here. The nth Fibonacci number is denoted as fib n of n. So it's simply fib n of n would be the nth Fibonacci number, that is equal to the sum of two Fibonacci numbers. So Fibonacci number of n minus 1 plus, and that's exactly what he's asking us. We just have to return this and we are done. We just have to return this statement and we are done with our logic. So basically what we've done here is, you know what the mathematical statement looks like, you know what the logic is, you just have to transfer that logic into code. And that is very simple because you exactly have the terminology. You know what Fibonacci number of n is. It's just fib n of n, guys, because this is how you call a function, and you just transfer exactly this into code. This is nothing but the n minus 1th Fibonacci number plus n minus 2th Fibonacci number, and this is the recursive function. But the thing is, so when you enter this function, you go here and it calls n minus 1th. So if you call the fifth, the recursive call, this call makes a call to 4, fib n of 4, and then again this function calls fib n of 3 and 2 and then 1 and then 0 minus 1, it goes on. But we want it to stop somewhere, and that is nothing but the base condition. So that should be accurate. And where do you want to stop? So the answer to the question when to break comes naturally in this case, guys, because we break when we know the answer. We stop recursion when we know the answer. The whole concept of recursion is solving the sub problems until we get to the point where we know the answer. So in this case, with an example, we need Fibonacci number, so the fifth Fibonacci number, and we know the answer when we know the answer to the Fibonacci number of 1, guys, which is the first Fibonacci number. The answer is 1, and we also know the answer to the second Fibonacci number, which is again 1. So we stop when we get to the point where n is 1 or 2. So technically we recurse when n is greater than or equal to 3, and we return, or in other words we break by returning a value 1 when n is less than 3. So we return 1 because the first and the second Fibonacci numbers are 1, guys. So using these conditions as base conditions, as base cases, we write the code as, so in this we are going to call the fifth Fibonacci number, and for that we write the code as this. Now we know the base cases, guys. If n is less than 3, we simply return 1, else we return. So the thing is, we don't need to write else here, because when we return 1 we don't go down, guys. So only if this if is not executed, only then we go down. So there's no need for else technically, so we can erase this else. So we can directly write, if not this, we return the last two numbers plus fib n of. I'll show you the working, guys. Don't worry if you don't understand the code as of now. I'll show you how this exactly works in the next slide. So now that we know when to break, we just elaborate a bit more with the mathematics. So we know that we return when n is 1 or 2. We just return 1, guys, because we know that Fibonacci number of 1 is 1 and Fibonacci number of 2 is also 1. The second Fibonacci number is also 1. So what we do is, when n is less than 3, that means it's 1 or 2, n is an integer, we return a recursive call to the previous two. But if n, I'm sorry guys, if n is greater than or equals 3, then we don't have an answer. If n is 3 or greater, we don't have an answer. So we just return the previous two, the sum of previous two numbers, hoping that we would get an answer some point later. But when we reach n less than 3, then simply we return 1. I'll show you exactly the working, guys. Don't worry if you don't understand the code as of now. I'll just show you how it works and then we can go to the code. So let's say we need the Fibonacci number of fifth Fibonacci number. So now it gives, so n, this is n right now, n is 5. Now since n is greater than 3, we return, we don't know as of now, we don't have any answer, so we just simply return the sum of previous two numbers. So this is fib of 4 plus fib of 3. And now we came to Fibonacci number of 4. We still don't have the answer. So we go to Fibonacci number of 3 plus Fibonacci number of 2. And even with this Fibonacci number of 3, we don't have an answer yet. So we go Fibonacci number of 2 plus Fibonacci number of 1. Now guys, in this case, we don't have an answer for Fibonacci number of 3. So we return Fibonacci number of 2 plus Fibonacci number, the first Fibonacci number. But in case of 2 guys, but in case of 2, we just return 1 because n is less than 3. We know the answer for Fibonacci number of 2, which is the second Fibonacci number, which is 1. So we just return 1 here. And in this case, Fibonacci number of 2 and Fibonacci number of 1, we know the values for these two. So we simply return 1 plus 1, which is 2. And this in turn returns 2 to this function, guys. So basically, Fibonacci 3 is 2 and Fibonacci of 2 is 1. We have solved the sub-problems and we have gained the answer. And we return these two values to Fibonacci number 4, and this becomes 2 plus 1, which is 3. This is the left subtree, and in the right subtree, similar guys, this is 1, this is 1, we know through this function. So the value is 2 gets returned to this, and now 3 plus 2 is nothing but 5, guys. So the fifth Fibonacci number is nothing but 5. So this is how you do it. And now to the code. Fibonacci number of n. I'm writing the pseudocode, guys. So technically this is the integer return type since it's a number, but you can make it whatever you want. And now coming to the base condition, we know that if n is technically less than 3 with this condition, guys, we just return 1. Simple, no rocket science. Else, so we don't have to write else here, because if this is not executed, then it goes to the next line. But if this is executed, directly it returns out of the function. It does not even go down. So we don't have to write else here. We can directly write the condition without having to bother. I mean, the difference between the return statement and any other statement here is, if there is any other statement, then if executes, and if I write print, for example, even this statement executes. But since it's a return here, if it returns, it never comes down. So we don't have to bother writing else. So we can just write if n is less than 3, we return 1, else we simply return the sum of the previous two numbers. So that's it with the Fibonacci numbers, guys. So this is the function you write. Simple. And we'll dive into more deeper, more tougher example in the next one, and hopefully you'll find some similarities to both of them. So here is the second problem, guys. As promised, a bit more tougher than the previous one. So the problem statement is, we have to add the digits of a given number until, so we have to do that repeatedly until we have a single digit. Here are the examples. So we have 38, we do 3 plus 8, which is 11, and we again, since this is not a single digit, we sum the number of digits again, which is 1 plus 1, and it gets to the point where the number of digits is 1, which is a single digit too, so we stop here. And similarly with 55, we sum the digits in this, which is 5 plus 5, it gets to 10, it's not a single digit, so we sum it again, we get a single digit, we stop here. If you would like to solve this without seeing the solution, please stop here, guys, and take a minute of time, take a couple of minutes of time. So the solution is pretty simple, guys. It's really similar to what we have solved before. I'll use the same terminology and the same thinking, the thought process to get to the solution. So as I said, we need two things. One is the base condition, and two is the logic. I'm sure you would have come up with the base condition, because the base condition is really simple here. We have to stop. The base condition is basically, where do we have to stop? We have to stop when we encounter single digit. So suppose we are given, so this is the function, guys, add digit, and the parameter is simply a number, and we have to return an integer whenever the sum is a single digit. So we would finish it like this. In this case, the base condition is really simple, so we'd go to the base condition first. So if the given number reduces to a single digit, which is less than 10, so 0 to 9 is single digit, guys. If it is less than 10, we simply return the number. It's as simple as that. But if it's not a single digit, what we do is we return the sum of digits, right? So for example, the number is 38. The sum, this is not a single digit, guys, so we return the sum of the sum of digits of this number, which is 11. And this is not a single digit either, so we return sum of digits, which is 2. And now this is a single digit, so we return the final answer. So now, to return the sum of these, if it's a single digit, we return, else we return, I'm just writing the pseudocode, guys. I'll just pass sum of digits, let's say sum of n, to the add digit. So let's say the sum of n is a function which implements sum of digits, which calculates, or which, I'll just show you guys, which calculates the sum of digits of n. I'll just write the sum function here, which returns an integer. I'm sure you would have seen this before, the sum function, the sum of digits of a number. It's simple, guys. You just break down. Let's say there is a result. This is the final result that we want to return. Now, while the number is greater than 0, what we do is we break it down using result and this. The logic is simple, guys. As long as the n is greater than 0, we are just taking the units digit and adding to result, and we are dividing it by 10. It works like this. So 38, suppose we want the sum of the digits of this number, we are breaking the units digit, which is 8, and adding to the sum, and then we are dividing it by 10, which makes it 3, and then again we are taking the units digit, which is 3, and adding to the result, which makes it the final answer. That's what we are doing, guys. And finally, after this while loop, we simply return the result. A combination of these two is nothing but our answer, guys. So this is as simple as that. I hope you understand what I've discussed. In the next tutorial, I would get to the trees and more complicated non-linear problems. If you have any queries or if you like any other videos, please comment in the comment section, guys, and please like this video if you've got all the concepts, and please subscribe. Thank you so much. It means a lot.